Okay, in this video I want to explain what indeterminacy diagrams are. Diagrams. So this is just something that some language that I'm going to add that it's going to allow us to describe the third indeterminacy appearing in Mochizuki's inequalities. So all right, so let me give a definition. So an indeterminacy diagram So they're going to look like diagrams, but right now it's just going to be a tuple, and then I'll draw the picture on the next page. S consisting of maps, okay, Fij, okay, from okay, and so this is going to be a maps of monoids here from psi I to Ri, from psi j to Rj, like so. So we have tuples like this. This will be for j bigger than I. So this collection is going to be so these collections over I are going to run over some index set, some ordered index set, and then we're going to have gi, and this is going to go from psi I to so these guys, for each node we're going to have a map to psi c c. Okay, so this is one indeterminacy diagram. It is a collection of morphisms like this where, okay, so let me just say what they are. So where Fij, so this is a morphism of monoid sets that can be partially defined. And these GIs, these are going to be morphisms of partially defined maps of sets. Or not partially defined, maps of monoid sets, not partially defined. And I guess this one could be partially defined maps of abelian groups with monoid actions. Not partially defined. Abelian groups with monoid actions are partially defined maps of sets with monoid actions. Okay? So this is what an indeterminacy diagram is, and here's the picture. So the picture is like as follows. So we're gonna have a bunch of maps here from the various nodes. Okay, and so here I've drawn it with an index set Z, and so that's really all we're gonna need is Z in our application, but I guess you could define this more generally if you wanted to. I minus 1 to I, Fi to I plus 1. Okay, and it keeps going, right? And then, so you're going to have G of I plus 1, G of I plus 1, G of I minus 1, like this. Okay, so this is what an indeterminacy diagram looks like. It looks like this drawing. So you have a bunch of maps like this, and then on each one of these nodes here, you're going to have, go back. Okay, you're going to have these monoid actions like so. Okay, so each one of these guys has a monoid action, and this is a partially defined map of sets or abelian groups, and it's equivariant with respect to the monoid action in the sense of the definition we gave previously. Okay, so so let me just give some terminology. So the object C is called the core. So this is what this thing is here. Okay, so this is what Mochizuki calls the core. Although he doesn't define an indeterminacy diagram, he just thinks that this notion, I think, is implicit. I don't know what he thinks. But anyway, we'll refer to this object C as called the core. Okay, so let me give some more terminology. So definition. So let S, okay, we'll start with these guys, Fij, Gi. be an indeterminacy diagram. So I'm going to define a notion of indeterminacies. See, diagram. Okay, so the collection of indeterminacies And so we're going to use these indeterminacies to define Ind3, which is one of the indeterminacies appearing in Mochizuki's inequalities, is the set. So this is the set of indeterminacies associated to the indeterminacy diagram. Ind S. It's going to be here. It's going to be a partially defined map of sets from the core to the core, right? Defined by the following. So it's going to be Ind S, and it's going to be the union for j less than I of gi composed with, okay, and now I'm going to have to define another set, ji, composed with gj inverse like this. Okay, so what we're going to do is we're going to define a collection of maps between nodes, and then after you conjugate, can I back that up? Yeah. So after you conjugate by these maps here, right, so I can go from here to here, right? So then you'll get a map on the core. So you could say go here, take all the indeterminacies from this one to this one, and then go back down. And then this collection that I'm going to define is going to be all the possible ways to go from here to here, given monoid actions, or these maps like this. So I could go here, take some monoid actions, and then go down. Okay? But let me just spell that out. So where Ind, so this set of Ind Sji, okay, so this is in here, M sets P from Rj to Ri for j less than I. Okay, so now I'm defining it for j less than I. Are defined inductively as follows. Okay, so now I'm going to write down 3 rules, or I guess 4 rules. Maybe I can, let's see, maybe I can squeeze them in here. I don't know if I'm going to ruin the slide here. Okay, so so first we're going to have that f, these ones are going to be in here. This is going to be an Ind Sji. Okay. 2 is that if W is an Ind Sji, and then for all okay, so then there's 2 things you can do. You can add a monoid action on the left or on the right. Then so we could say W composed with psi j is in Ind Sji, and psi, okay, so I ran out of space. So I definitely ran out of space, and what I did was I just wrote them out instead. So if we have an indeterminacy diagram, then we define a collection of indeterminacies by the conjugation of local indeterminacies, which are maps from one node that's smaller than another node. And what we do is we say that, okay, first of all, the basic ones are in there, so that's kind of the base case. Then we take a closure, left closure and right closure under the monoid actions, and then we say that finally we say that if we have an indeterminacy to a middle node, right, we can take one of those maps and then compose it with from the middle node to the end node, and get something that's in our indeterminacies. So those are the closure conditions. So the one last thing I need to add is to explain how indeterminacy diagrams give rise to actions on regions. So if let's say S is an indeterminacy diagram, and let's say C is the core of the indeterminacy diagram, and omega subset of C is the core, then we will let omega ind S, so this is going to be defined to be equal to the union over gammas in the collection of indeterminacies of gamma of C. Okay, so this is how collections of indeterminacies act on regions. And so the point is that to define a third indeterminacy in IET3, we're going to construct an indeterminacy diagram, and it's going to act in this way. All right, I'm going to do that, and that's going to be the Log-Kummer correspondence.